All right, as I was saying, today we're going to start working within sorting algorithms. In this problem, it's called sort the odd. And you will be getting an array of numbers. You have to sort the odd numbers in ascending order while leaving the even numbers at their original positions. Great. So let's take a look at what that means. If we have 7 and 1, that is only in a list of odd numbers, and we can see that it turns into 1, 2, 7. We have 5, 8, 6. That's an even number. 3 and 4, 4, which is also an even number. We can see that 3 is being sorted to the beginning. 8 has remained in place. 6 has remained in place. 5, which is an odd number, has been switched. And 4 has remained in place. And then finally, we have our final example where we have 9, 8, 7, and so on. And we can see how all of our even numbers retain their current location, but our odd numbers, with the exception of 0, it looks like 0 is being considered an even number here, is also being pushed to the right. Oh, is it being? Yes, it is being considered an even number. It's also maintaining its current location. So with that said, let's start taking some edge cases into consideration. It is safe for us to assume that all inputs will be valid. So with that said, how would we go about solving this problem? What kind of algorithms can we use, and what considerations should we have whenever we're working with this within this algorithm?
I was just thinking maybe for finding like the odd number, use like the modulus operator,
Okay, so
maybe to
fine,
pick out the numbers.
perfect. So find even numbers by num modulo 2 is equal to 0, means it's even. Okay, or we could shorthand this and just say, actually, I'll leave it like this for now, and then we'll go over shorthand later on once we start seeing this in action. Okay, so there's how we'll be able to identify our odd or even numbers. I apologize. What about the sorting algorithm that we'll be utilizing?
Could use whenever you do find the odd numbers, do a binary search.
Okay, so we could utilize a binary search to find indexes. Is that the clue here? We want to find the indexes of these numbers?
To find at least how I'm thinking, to find the values of the numbers and then their indexes to be able to switch their locations if they're higher or lower compared to each other.
Okay, so find both the indexes of odd numbers and values to then sort. Is that what you're going for here?
Yeah, for sorting the list
Okay,
essentially of odd numbers.
got it. So we're finding the locations and values of these numbers utilizing a binary search. So binary search is awesome if we're trying to find something. But in this case, I think we're trying to sort something. So although this is a valid way of going about solving this problem, there's probably a better algorithm that we can utilize to actually sort this list here.
Couldn't we use one of the ones that we went over the other day, bubble sort or insertion?
Okay, awesome. So we could utilize bubble sort or insertion sort. Bubble or insertion sort. Which one's better in time complexity?
Insertion, I think, or are they the same?
Insertion, yes. So insertion, better time complexity. All right, Gary?
I was thinking of using the filter function.
So utilizing the filter function. So the filter function returns a list, how would you go about utilizing the filter function?
I was thinking that it would filter by going through the list and only return the numbers that are modulus 2 with the remainder of 0.
So then you would end up with two lists. Is that what you're saying? Have two separate lists, one where it's your odd numbers and one where it's your even numbers, and then go about merging them later on?
I suppose, yeah.
Okay, so let's take that into consideration as well. Let's say break into two lists. One that will hold all of our odd numbers, and where the other would hold our even numbers. And sorting odd and then merging. Okay. And I guess that your method, Gary, would go hand in hand with the binary search method, because you would also need to find a place to merge those even numbers back again. Okay. All right, awesome. So we've taken a couple of things into consideration. I definitely think that the best bang for our buck is going to be to invest time in the insertion sort algorithm. And we just need to find a way to implement this, right? At which point, or how would we alter the algorithm so that we can recognize, hey, if this is an even number, then you need to hold its place within the algorithm, within the list that we already have. All right. Okay, does anyone else have anything they want to recommend before we break up into our groups? All right, since we don't have any recommendations, let's go ahead and you guys can put this together. All right, awesome. So here we are. We have our sorting problem where we want to sort through all of the list. Well, I'm just going to simply try to implement my insertion sort here. So I'm just going to pretty much take in the code and say for IDX in range, and excuse me, this is not a range. I'm just going to say for location in, oh, this is definitely an index in range of 1 and the length of the list. Then in here, I want to set an item, which is just my placeholder, right? We go back to our drawing when we covered this. Let's see, I believe it's this one. Yeah, here we go. Here's our drawing of what we created last time. All right, so we have IDX, which is going to be set to our green number, that very first index. So in this case, I'm going to use list at IDX. In there, I'm going to have JDX, which is just going to be equal to IDX minus 1. From there, now that I have my indexes, or what I'm selecting, one of them is an item, the other is an index. In this case, the index will be pointing at the number 4. I actually have to point at it. So I'm going to say, hey, while J is greater than, or excuse me, JDX is greater than or equal to 0, then I also want to check if the item is less than the array J, or excuse me, the list JDX. Now, is there something else that I want to add into this while loop? Is there another conditional statement that should be taken into consideration here?
I have to add an if statement, filtering odd numbers versus even numbers. You filter out the even numbers.
Okay, so let's go ahead and do a helper function saying is odd to find out if it is actually odd. What it will take in is a number that is represented as an integer, and what it will return will be a Boolean of true or false. Now, this function of is odd, how is it going to work? For now, let's just write pass down here. How do I determine if a number is odd or not?
You said you was gonna show us like the shorthand, but like modulus 2 or like the number or whatever, and then if it's not equal to 0, or you could however you want to word it.
So we want to return the modulus of 2. And remember that numbers are truthy or falsy. So if this is 0, that will evaluate to false, which is perfect because I want is odd to return false. If it is 0, that means it's not an odd number. And if it evaluates to a 1 or a 2, then it will return true because it evaluates to a true. All right, so we could just change this a little bit and just put bool here so that we can actually get the Boolean value. All right, I see a question from Owen.
Yeah, is that statement where you said if a number is 0, it's false? Is that the same in JavaScript, or is that just a Python thing?
That's the same in JavaScript, yes,
Okay, thank you.
of course. All right, so then we have our is odd, right? So now we're checking, hey, if JDX is greater than or equal to 0 and item is less than the list at JDX, and now we also want to add another AND statement. And what do we want to check here? Do we want to check if item is Boolean, or do we want to check if list JDX is Boolean?
Item.
All right, let's try that out. Let's say is odd and pass in our item. And let's just finish out our while loop here. Then we would say list JDX plus 1. Oh, hello. Apparently I can't type. Is equal to list, or excuse me. Yes, it is. It's equal to list at JDX. And we would say JDX minus equals 1. And finally, once our while loop is killed, we would call the list at JDX plus 1 and set that to our item. And then at the very end of our entire loop, we would return our list. All right, so there's quite a bit to unpack here. Let's go ahead and add a couple of print statements. Let's go ahead and print inside of our for loop here. And then add an F state or a print statement there. And I'm going to go ahead and put our items. So our item is officially just item. I want to see the JDX value. So here we'll go ahead and throw the list at JDX. Then I want to check if item is odd. And we will see that. And is odd at list, or excuse me, at item. All right, and then at the end of every iteration, before it moves on to the next one, I want to see what list looks like. And actually, for simplicity's sake, I'm going to go ahead and put that into an F string as well, so that I can have some white space in between each print statement. Okay, so now let's go ahead and run this test. Currently, I'm just utilizing test 1. We're going to go ahead and run pytest for test.py. All right, so we're seeing that it failed. And let's see what we're doing here. So let's start from the very beginning. We have our item, which is the number 3. We have JDX, which is our list with the value of 5. Item is odd is equal to true. All right, so our original list was 1, 3, 5, 2, 8, and 4. Or excuse me, that was not our original list. Let me take a look. 5, 3, 2, 8, 1, and 4. All right, great. It did not meet my statement here because 3 and 5 are not greater than one another, so they stay on ascending order. And I get 3 and 5 being printed on my list. Then I get 2 and 5 But now we're checking if the number is odd. We get 2. Great. So everything stays the same. Now we get 8 and 2. We also get false. But now when we move on to 1, well, when we moved on to 1, this statement is true, right? And the number 1 changes all the way down below to the 1. So now we get 1, 3, 5, 2, 8, and 4. So I think that's where our problem is. We did, in fact, switch the location, but notice how the index of the number 2 has now changed. Right, so 5 should have been after 2. All right, so we are sorting correctly. We do have our 1, 3, 5, but 2, 8, and 4, even though they're not being impacted, their index is changing. All right, awesome. So there's something else going on inside of this while loop that we need to alter to get the finished product. Does anyone have any ideas as to what else we need?
Should we have passed IDX in the isOdd function or no?
Yeah, it's a good question. Well, we do have our isOdd function, and I think changing it between item and the list item at JDX isn't necessarily going to change our result, but let's try it out. Let's say list at JDX. So we still get an assertion failure, and I do think this actually makes us go backwards, because now if you can see, our final product does not work the way we intended to, right? So let's go back and switch that to item. I believe the original statement we had was correct. All right. The rest of the algorithm, or the remaining portion that we need to change, needs to happen within the while loop. So here within this while loop, we need to ensure that whenever we're reassigning our variable, whatever we're reassigning to, it's keeping that number that is even in the correct location. And unfortunately, we are out of time. So I'm going to go ahead and stop the recording here, but I'll finish demonstrating this, or at the very minimum, push it in demos and notes. All right, let me go ahead and stop our recording.